All right, now we're actually going to put that full kind of hypothesis testing process together and actually really implement it from start to finish here. So in section 7.2, we're focusing specifically on hypothesis testing for the mean when sigma is known. This is really important. So there are two different procedures for when sigma is known and unknown, just like there were for confidence intervals. So in section 7.2, we're focusing on sigma is known. So again, remember sigma is the population standard deviation. And then in section 7.3, we're going to look at when sigma is unknown, which is what I think probably occurs more often than not. So we'll look at both of those pieces. And again, we're just going to focus on means here. So you can do proportions. You can also analyze variances as well. And those are in later sections in chapter 7 if you're interested. Now, I broke up 7.2 into two parts. So in this first part, we're going to use the p-value method for hypothesis testing, which is really what we focused on in 7.1 as well. So I'm going to kind of continue with that same idea. And then in the next set of videos, we'll focus on a second method called the critical value method. All right, so again, as I mentioned, there are two strategies when we hypothesis test. We have the p-value method and the critical value method. And in this handout, we're going to focus just on the p-value method and kind of break them up a little bit. And again, I like the p-value method. I think it tends to be used a lot more because it's very easy to use with technology. So it's a nice method, and you do see it a lot. If you see p-values in research and stuff like that, they're using the p-value method to use their hypothesis testing. So just to recall, how do you make decisions with the p-value method? It's based on the p-value, which is the probability, and the alpha that you have chosen. Okay, so keep in mind that the p-value here, it's just a probability. And again, your alpha is called your level of significance, which is usually 0.01, 0.05, or 0.10, which represents like 99% confidence, 95% confidence, and 90% confidence, okay? Now, when your p-value is less than or equal to alpha, you are going to reject the null hypothesis. Basically, you're saying if your p-value is less than or equal to alpha, this is unusual, so something's wrong. So you're going to reject the null. If your p-value is greater than alpha, then we fail to reject the null. So for instance, let's say the p-value for a hypothesis test is 0.0237. So our p-value here is 0.0237. And in part A, we're going to let our alpha be 0.05. So what do you think? Let's compare our p-value to our alpha. So 0.0237 and 0.05. Well, this is smaller than this one, right? 0.02 and 0.05. 0.02 is smaller. So we're saying here that our p-value is smaller than our alpha. So if our p-value is smaller than alpha, we would reject the null hypothesis. Now in the second example, so our p-value is still 0.0237, and our alpha this time is 0.01. So if I compare our p-value with our alpha, okay, 0.02 versus 0.01. Well, 0.02 is bigger, right? So we're basically saying here our p-value is greater than our alpha, so we're going to fail to reject. Oh. So that alpha plays a really key role sometimes on if you're going to reject or not reject. And remember that alpha represents your type 1 error, just as a little side note. So I mentioned before in the end of the last kind of video there, when we actually do hypothesis testing in the real world, it is really important that you choose your alpha cutoff before you get your data. Because if you have your p-value already, then you could choose whatever alpha you want to get the decision that you want, right? And that's not ethical. So before you go into a project, you should have your claim, your null, your alternative hypothesis, and your alpha all selected and then you see what the data says. Then you sample and see what it says. So again, you just want to be really careful because it's very easy to be unethical here and kind of do your values first and then choose your alpha at the end to get what you want. And you don't want to do that. You want to make sure that these decisions are made before the sampling and the data calculations are done. So the lower the p-value, the more evidence there is in favor of rejecting the null hypothesis. So if the p-value is very, very low, like 0.0001, then choosing the alpha isn't going to matter as much because 0.0001 is so small, it's going to be less than all your alphas likely. But here, this is still pretty small, right? That would be like 2.37%. But the alpha does matter. It depends on what your cutoff is. So for example 1, we would reject the null hypothesis at any significance level less than or equal to the p-value, right? So if I chose alpha is 0.01, then I could get a rejection there for the null hypothesis. All right, now how do you actually find a p-value? So after determining the hypothesis standardized test statistic and the standardized test statistics corresponding area, we're going to do one of the following to find the p-value. So again, I haven't told you how to find the test statistic yet. I will. It's not as hard as it sounds, but we'll get there. We're kind of working backwards. How do you find the p-value? Well, this is very similar to chapter 5. So for a left tail test, your p-value is the area in the left tail. For a right tail test, it's the area in the right tail. And for a two-tail test, basically you're adding up the area in both tails. So what you can do is just find the area in one tail and double it because it's going to be symmetric and the same on both sides. So that's why you have this 2 times. You just find one of the values and then you can double it. Sorry, this should be a dash there, not a 0. So find the p-value for a left-tailed hypothesis test with a standardized test statistic of z equals negative 2.23, and then decide whether or not to reject the null hypothesis. All right, so I'm going to draw my picture first. Now again, we're using z values here, so my center must be 0, right? That's my mean. And I'm using a z value of negative 2.23, so it's going to be somewhere on the left. And I'm using a left-tailed test. So if I'm using a left-tailed test, then my shading is on the left. Okay. So this area here is equal to your probability, which is equal to your p-value. So think back to how we found this. If you're using a calculator, we can do this and use that normal CDF function. So you're gonna press second and then bars and then normal CDF. And remember, you use your lower bound, your upper bound, your mean, and your standard deviation. So in this case, this is going to keep going left forever. So my lower bound is negative 9.9999. My upper bound is at negative 2.23. My mean is 0, and my standard deviation is 1 here. All right, so let's see what we get. Hang on. All right, so second bars, normal CDF. I go from negative 999 to negative 2.23. Type in my mean and standard deviation, and I get about 0.012873. So I'm going to round to 4 decimal places, 0.0129. Now, if you're not using your calculator, if you're using your tables, then that's actually fine too. So if you need to go back to chapter 5 here, so this is all chapter 5 stuff. Okay. So if you need to go, actually 5.1 really, for being specific here. If you need to go back to chapter 5.1 and do a review here, please do that. If you're using your table, get my table out real quick. Sorry, big books here. So if I get my table out and I'm looking at negative 2.23, so I have negative 2.2, and and I see I get 0.0129, which is the same value that I got. Okay, so you can either use your tables, or you can go back and use that formula for the calculator. So there's actually really nothing new in this part of it. So your p-value here is 0.0129 or about. Now we're going to use an alpha level of 0.01. So I'm going to compare my p-value to my alpha. So I have 0.0129 and I have 0.01 here. Now this one is a little bit bigger, right? Because it's going 0.0129 and this is 0.01, which would be 0.00 next. So 29 is bigger than 0.00. So this is bigger. All right, so if I go back here and I think about this, I look at my information, if my p-value is bigger than alpha, then I'm going to fail to reject the null hypothesis here. All right, let's do another example. All right, so we're going to find the p-value for a two-tailed hypothesis test with a standardized test statistic of z equals 2.114. And then we're going to decide whether to reject the null hypothesis after that. Now, again, notice I have z-scores. If you see z-scores, then don't forget your mean is going to be 0 and your standard deviation is 1. Anytime you see z-scores, so that's an automatic there. Now, if I'm doing a two-tailed test, then that means I have coloring on each side. And we're told our test statistic is z equals 2.14. So I'm putting it on the right because it's positive. Now this is a total symmetric mirror image. So on the left then, value here is negative 2.14. Because they're symmetric, these two areas are going to be exactly the same. So you don't have to find both areas. You can just find one area and then double that value. And that's the faster way to do it. So I always suggest finding the area on the left if you're using the tables, because the table in the back of the book is always area to the left. That will be faster for you. If you're using your calculator, it's not going to matter. So I'm going to use my calculator for this one. And if you use your calculator, you can find the area on the right too. It doesn't matter. So here, I'll do the area on the right. How about that? We start at 214. I'm going to do this one. We go up to positive infinity here. My mean is 0. My standard deviation is 1. And I get about 0.016177. I'm going to stop there. Now, just be careful. You have to actually double this area, right? So we're going to multiply this by 2 because that 0.0162 will say is on both sides. It's perfectly symmetric, so it's the same area on both sides. So when I multiply that by 2, just multiplying it by 2 in my calculator, I get about 0.03235 if I'm rounding to 2 decimal places. Now, in your book, they're using the table here. So they're using 0.0162. Oops. So they're using 0.0324 for their value here. So I can round that way too, actually. If I round to 4 decimal places. So you may have, again, just some slight variations with technology in the table, but you should be very, very close. So if I round this to 4 decimal places, I do get the same answer as the table in the back of the book here. So this is our p-value. Okay. And now I'm comparing our p-value and our alpha. So 0.0324, our alpha here is 0.05. 0.03 is definitely smaller than that. And if you go back to the page before, when the p-value is, where is it? Sorry, smaller than alpha, we're going to reject the null. All right, so let me give you the steps for the full process, and then in the next video, we'll go through some examples. So using p-values for a z-test, and a z-test is used when when sigma is known. Okay, so again, we're looking for means here, and sigma is known. So we can use a z-test in this case, and we will find that sample statistic here using basically a regular z-score formula, except for we're dividing by the sigma with the square root of n. So similar to using that central limit theorem that we had before. So your formula for that test statistic is going to be this one right here. You do need to make sure, just like the central limit theorem, that you do fulfill these requirements. So your sample is random, of course, and that either the population is normal or your sample size is at least 30. So you have that same restriction before you can start hypothesis testing for means here. All right, so here are your steps for how you hypothesis test using p-value. So this is the p-value method. So first, again, verify that you actually do know sigma. Your sample is random, and either the population is normal or your sample size is greater than 30. So basically, this first piece here is sort of your requirement check before you can start. Then you're going to state the claim. You're going to state the null, and you need to state the alternative hypotheses. You have to write all of those out. I know it doesn't say to write the claim here. I'm going to write it in. State the claim as well. You are going to choose the level of significance. Now on the homework, they will tell you what to use, but in real life, you would choose the alpha that you're using. Now you're going to find, here's where the calculations really start. Find that test statistic. So you're going to find the z value that marks the edge of the shading. You're going to find the area for the z value, or you can use your calculator here. So second, bars, normal CDF, lower bound, upper bound, mean, and standard deviation. Make sure you figure out if you are doing a left-tailed, right-tailed, or two-tailed test. So you can kind of do this all at the same time. As you find your p-value here, and then of course you're going to use that cutoff of comparing the p-value to the alpha to make a decision about rejecting or failing to reject the null hypothesis, and then you're going to state that interpretation in words. It does help to sketch a picture too along the way, so it doesn't say you have to sketch a picture here, but this would be a good time to draw a picture as well.